morning. I'm here to talk about the Phoenix Web Framework. And before we get started, a very quick glossary, okay? Phoenix is a web framework that is implemented with the Elixir programming language that runs on the Erlang virtual machine, okay? Those are the three technologies that we be mentioning on this talk. So just wanted to be upfront about them, okay? So let's get started. Who here is familiar with the WhatsApp case? Okay, almost everyone. That's really good. But WhatsApp is a messaging application that you install on your phone, and they got really popular. Not popular. They were really commented about, talked about the last year, 2 years ago, because they were acquired by Facebook by 19 billions, uh, and everyone was surprised because they are one of the biggest messaging applications out there. You install it on your mobile device and then you can exchange messages with your friends. And even for being one of the biggest ones, they had a very small engineering team. At the time they were acquired, there were only 10 engineers. And they were quite open about their infrastructure and how they were doing things internally. So they did this blog post some time ago where they're saying they had 2 million connections on a single node. So what's happening here is that they had a single node running production. They had more nodes, but one particular node running production was able to handle 2 million devices connected at the same time, sending and receiving messages. Okay? So and when we go and we look more information in the blog post, it's a quite powerful machine, right? It says, oh, it has 24 cores, 96 gigabytes of RAM. But even though with all that resources and all that load, it was using only 40% of the CPU and memory. And when we look at this, now in 2015, this is exactly what we want, right? We want to build software that is going to run very efficiently on my machine with two cores and 4 cores. But when I put into production and it has a very powerful machine, we also want to use those resources as efficiently as possible, okay? And and they are able to do this because they run everything on their Erlang virtual machine. So how is this related to Phoenix? Chris McCord, the creator of Phoenix, he was looking at those cases, okay? And he was saying, wait, what if I could use this technology, right, to build my web applications? What if I could, he was working with something that required more like real-time features. So he was looking at this like, I'm struggling a lot to do this on the technology I am currently on. What if I can use then the Erlang virtual machine to power the stuff I'm going to build in the future and make this much easier. And that's how Phoenix got started. It got started mainly with an abstraction called Phoenix channels. So a Phoenix channel it's an open communication channel between the client and the server. So it is kept open, and then you can send and receive messages anytime you want. So one example of such communication channel can be between a browser, right, and the server. And if you're talking about the browser, we are very likely going to use JavaScript, okay, or something that compiles to JavaScript anyway. So so if you're talking about channels, here's some code. So here's the client-side code, because if it's an open communication channel between client and server, we need to write code for both sides. So on the client, we have this. On the first line, we are saying, hey, I want a Phoenix socket, and I give it the endpoint. Okay, and then on the second line, I call socket.connect. And now I am connected to the server. The communication channel is established. And now I can say things like, hey, I want to join on this channel. And the channel we have here, we can imagine is a chat application, right? So the channel I have here is the chat lobby. And after I'm inside the channel, I can do things like every time the user joins, I want to change something in my UI, for example, right? Every time a new message comes from the server, so every time we say channel, chan.on, I'm reacting on messages coming from the server, right? Every time there's a new message from the server, I want to do something else, and I can also react on the UI, right, and send new messages to the server. And in order to make this work, so this is the client side, in order to make it work on the server side, all we need to do is that we need to define a router. So here's some Elixir code. I'm defining a router, and I say, well, I'm going to have my socket endpoint at this particular route. And now every time the user tries to join the chat lobby, I want to handle that logic in the lob channel module. Okay, every time the user tries to join a particular room, like room 1 or room 13, I want to handle that in the room channel module. And those modules, they are straightforward to define. So all I need to do is that I define the module, say I want to use the Phoenix channel features, and I need to define one function called join. So in this case, I'm defining a function called join that is going to receive all the user parameters when the user is joining. And I can do things like authorize in this join function, for example. Hey, is the user appropriate to do that? We can imagine that in this particular case, it's like a public chat thing, right? So every time the user joins, the only thing I do is to broadcast to everyone, hey, the user joined, and here's the message, or here's the username of the user. And that's it. And then every time the user sends something from the browser, I can define other functions to handle that code. So we here at the bottom, we have a handling function that is called every time the user sends a new message. And what do we do when the user sends a new message? We just broadcast this message to everyone, right, in that channel to let everyone know that the user just said that. So you can be looking at this and saying, okay, right, it's nice, but there's nothing really new here, right? We can see other technologies doing that. So what is the difference? How is Phoenix different, this channels feature, from everything else? So in order to answer that question, let's take the outside view here. And the main difference, we already got an idea from the WhatsApp case, right? So one thing that we are sure we're going to get with Phoenix, because it's built on top of Elixir and the Erlang virtual machine, is that it's going to at least scale vertically, right? Because the WhatsApp, they're running a very powerful machine and we're using our source there efficiently. So that's already a really, really good thing, okay? Something else that we get from Phoenix is that we say that the channel transport is agnostic. So here, if we have the outside view, I have the server with an open connection to the browser. But because the transport is agnostic, right, we can have another client that is running on a browser, for example, like Internet Explorer, that doesn't have WebSockets, so you need to emulate another transport. But if you have a native mobile application, okay, it's going to be fine too. And if you have a custom protocol running on a native mobile application, or even if you have an embedded device. So we already have experiments running on CoAP protocols or MQTT, and it doesn't matter from the channel perspective. It's just the transport layer, and we abstract that. So that's another cool difference, right? We are transport layer agnostic, and we said that we can scale vertically, right, easily. We saw the WhatsApp case. But not only that, we can scale horizontally very easily too. Because so if let's suppose you deploy to production and everything is running fine on one machine, and you say, oh, I need more machines to start handling this load, the load that's coming. So what we do is that you can just start another server, right, do a very minimal amount of configuration, and now the different nodes, they can all talk to each other. So if, for example, the user disconnects, right, and then it connects to the other server, everything is going to run just fine. The messages, they're going to flow for the system. So this is nice, okay? Now we start to see, hey, this thing is really paying off, right? It's getting really, really interesting. But to me, it gets even better when we go to the inside view, okay? So that was the outside, right? But now let's do the inside view in the server. Okay, so on the left side here, we have the client, and on the right side, we have inside the server. So every time the client connects, right, we create a new process on the server. And from this moment on until the rest of the talk, every time I say process, I do not mean the operating system process. What I mean is a very lightweight thread of computation that exists in the Erlang virtual machine. And we can create literally hundreds of thousands of those. In the WhatsApp case, they had 2 million connections. They had at least one process per connection, which means they had at least 2 million processes. Okay, so it's fine. We can create a bunch of those. And so that's what happens. Every time the client connects to the server, we are going to create one process that is responsible for the transport. So when we call socket.connect on the client, it creates this process. And now every time you join a different channel, it's going to create a process for that channel too. And the benefit of doing this is that those channels, those processes, one for each channel, they are isolated and concurrent. Why this matters? So, and this is, it's something that it's very hard to offer elsewhere, and Phoenix offers it very cleanly, which is the idea that those channels, they're isolated and concurrent, is that if something goes wrong in a channel, so let's suppose you have like chat lobby, room ID 1 and room 13. If something goes wrong in room 13, everything else is going to continue running, right? Because they are isolated. So if there is an error in some particular code that happens in a room, okay, the system is going to be fine, right? Everything is going to continue running. Even more important, there's not going to have an exception that's going to bring everything down and maybe force a disconnection. And this matters because if you're talking about embedded devices, for example, maybe establishing a connection is expensive. So we really want to have the channels isolated from the transport. And we have very good guarantees for that when writing Phoenix in Elixir. Okay, so that's nice. And it's also concurrent, which means that if one channel for some reason needs to, I don't know, talk to a different API, it's not going to block the other channels, right? They're all concurrent. They can all run at the same time. And we basically got all those guarantees for free, basically by modeling all those things as processes. So that's how it looks in the inside view. We now know that channels, they are concurrent and isolated. And to finish this, we also have a pub subsystem that runs with the channels that is responsible to synchronize the data between the machines, right? So I said if you have multiple servers, everything's going to just work, and that happens thanks to the pub subsystem. And we have different like backends for the pub subsystem. So the default one uses just the distributed Elixir, distributed Erlang to have the machines talk to each other. But if you're running on Heroku or a place where you cannot really make one machine reach another directly, you can push things to Redis. And we have experiments with Postgres, XMPP, XMTT backends also, and so on. So that's the Phoenix introduction, okay? So that's how Phoenix got started, right? And with time, the Phoenix team actually realized that, wait, we started with this, and we can be much more than channels. And if you go to the Phoenix web page today, this is what you have. It says Phoenix is productive, reliable, fast, and you can build HTML5 apps, API backends, distributed systems with it, and so on. So if you want to, so what I want to focus on this talk is not the how, it's not how we're going to build stuff. Okay, you can check the guides to learn that. I want to focus on the whys, how Phoenix is going to allow you to be productive, reliable, and fast. And one of the main ideas with Phoenix, and that's why we have on the homepage, is that many frameworks, they make you choose between productivity and performance. They're like, hey, if you want to be productive, right, you know, performance is going to be really bad, but you're going to be super productive. And there are other frameworks that say like, oh, if you want performance, come use this. You're going to be very close to the metal, right? And then you're going to get good performance, but you don't feel very productive. You need to abandon a lot of the tooling. Maybe you need to write a bunch of callback spaghetti code and things like that. So if we're talking about productivity, reliable, and fast, okay, I want to start with performance just to get it out there. And in order to understand why we have such a good performance, okay, I want to go back to before I show some numbers, I want to go back to the inside view very quickly. So here we have the client, right? And we said every time the client connects to the server, we have a process. And that was the case for channels, and it's the same for handling regular HTTP requests. So every time there is a new connection, right, we're just spawning different processes. And as we know, those processes, they are isolated and concurrent, which if we recap, right, it means that crashes are isolated. If something goes wrong in a request, the others are going to be fine. But more importantly, data is isolated. Each of those processes, they have their own data, which means that we don't need to have like global garbage collect pause that's going to pause everything to do a garbage collection. So if we use Java, Ruby, Python, whatever, right, you can build an application that has a very good response time on average, but when you go to the 99th percentile, to the end of the curve, you have users waiting a lot, and those are the unfortunate users that kick the garbage collector, right? And then they need to wait for the garbage collector. Here it doesn't matter, right? The data is per process, so garbage collect is per process. There are no global pauses. Sometimes for fast requests, we even do the request and then we don't garbage collect at all. When the request is done, we just reclaim everything back. It's really, really fast. And because it's concurrent, it load balances on I/O and CPU. It's going to be efficient on multi-core. So I'm going to show some numbers. I don't have a lot of time to go over them, but it just gives an idea. And the disclaimer, you can go to the web page. So here are some numbers. Okay, you can go to the web page for more information. But just what I like from this, right, is that you can see that we are comparing different things in Elixir, Go, Scala, Node, and Ruby. And you can see here that plug is an abstraction around web servers in Elixir. You can see here that plug is at the top of this particular benchmark, and Phoenix is coming second. And what I like about this benchmark is that even though Phoenix is a web framework and it adds a bunch of things on top of plug, which is a very thin layer around the web server, it still has very good performance, right? We lose just 10% of the throughput by adding all the web framework stack. And that's really good. It means that when you come and you add your code, it's not going to go much lower than that. So for Phoenix, we're about 180K requests per second. And this is on a machine with 10 cores. You can check the URL for more information. Cool. So I don't want to talk. I don't want to go very long about performance because what I really want to talk about are the other two things, right? Being productive, and writing reliable software. Okay, and as we will see, those are a little bit interconnected because when we talk about productivity, I like to think about productivity in two ways. I like to think about short-term productivity, and this is, when you're getting started with the project, how quick it is for me to have something up and running, or you are building. It can be when you first started with the language. So if you watch this talk and say, hey, I'm really excited about this. I want to try this Phoenix thing out, right? It's a new framework. It's a new programming language, right? It's a new paradigm. So how easy it's going to be for you to get started and understand the concepts, okay? So short-term productivity, it's a lot about having good documentation, having good guides, having a very good tooling or a very good workflow that allow you to just focus on what you need to do at the beginning, okay? But we also need to think about long-term productivity. A lot of web frameworks, they really focus only on the short-term productivity. They even value it too much to a point where it can affect negatively the long-term productivity. But we are extremely worried about being productive in the long term too. And that means how easy it is to change my code, right? After 6 months I'm in the project. If my project is growing too big, how easy it is to break it apart. And also, if you're working on a project for that long, it's hopefully running in production. So how easy it is to maintain the system up and running live, right? Can I introspect the system? How easy it is to monitor it? So to start with the short-term productivity, right? So one thing that we have is having generators learning tools. And I was worried about the name generators because people may expect it to be something that's going to generate your whole application, right? You just call it like 20 different times with different parameters and boom, your application is done. No, it's not that. We treat generators here mostly as a learning tool. As I said, they are coming to a whole new web framework, a whole new language. So we want to have those things that's going to show, hey, how do I create something that it's an HTML based, like how do I write something that's going to generate some forms? I can get those form results, input into the database, and so on. Okay, so that's what phoenix.gen.html is going to do. But if all you want is to build an API backend, you can call the JSON one. Or if you're more interested in the real-time features with channels, you can call the channel one. That's going to generate some code, a minimal amount of code really, for you to understand how all the pieces fit together, and you can continue to do your work. And if you're talking about short-term productivity, a lot of things that you expect in other web frameworks, they are already here in Phoenix. So we have, if you very likely want to talk to the database, so we have a great tool called Ecto. Ecto would be worth a talk of 30 minutes on its own, so just check it out later. If you want to do HTML stuff, you need to have form builders. You need to have build tools that's going to handle CSS and HTML and JavaScript for you. And when things go wrong, you need to have very good tooling, right, for debugging your errors, for testing your projects. And at the last bullet here, we have also a package manager called Hacks. And it was really nice because last week we hit 2 million packages, downloads, not packages, but 2 million downloads. And the community is growing, and as more people come, we are having more tools ready and available. So you don't need to solve a problem if someone has solved it in the past, right? And these are all things that I think it happens a lot. It helps a lot on getting started on the short-term productivity. But even more interesting than that is the long-term productivity. And in order to talk about both long-term productivity and how we write and how Phoenix can help you write reliable systems, I want to explore the last topic of the talk, which is the idea of applications. Okay, so this is our last stop. So applications. We had that inside view, right? Where we had the client here on the left, and then it connects to the server and it opens up the process. And as different clients are connecting, right? We are we are creating those different processes, and all those processes they are kind of managed by the TCP acceptor because you have the TCP acceptor is waiting for people to connect, right? And then you are creating those processes to handle all those requests. Okay, so we have all those processes here at the bottom. We have the TCP one on top, right, which is another process. So that's running our system. That's some processes running our system. But not only that, we said, for example, that I have a pub sub system, okay? So, and everything in Elixir, it runs inside those processes. So if I have a pub sub system, okay, I'm going to have a pub sub process that's going to do something else. If I want to talk to the database, I'm very likely going to have a pool, right, and a process to manage the database connections, the pool of database connections. So when we start having all those entities, right, and we said that they are isolated at first, if something goes wrong, it's not going to affect the others, we start to ask the question like, hey, what's really going to happen then if something goes wrong with my pub subsystem, okay? So we start to think, what is going to happen when things go wrong, when something that you did not expect happen? And what we do is that we then start adding those things called supervisors, which their role is exactly how they are supposed to react when something in your system goes wrong. So, hey, if the pub subsystem process went down, what should we do? Maybe we should start another pub subsystem process to continue doing what the pub subsystem is supposed to do. And that's exactly what happens, right? So we start having all those processes, and because if something goes wrong, we want the system to continue running, to go back to its healthy state. We start defining those supervisors, right? And sometimes the supervisors have supervisors too. And we have this thing that starts to look more and more like a tree. And that's what we call a supervision tree. And when we have a supervision tree with all the processes in my code, right, I package these inside an application, okay? So this is something extremely important to understand when you get to Phoenix, because when you write code in Elixir, all your code exists inside applications. Okay, so what is an application really? It's applications, they package and run our code. And when we run a Phoenix, when you start your Phoenix project, we're going to see some examples soon. It's not one application, it's a bunch of applications running side by side, right? So the application is going to package and run our code. And the applications, they can be started and stopped as a unit, okay? So all the initialization and stopping code is there in one place. Not only that, applications provide unified configuration. This is one of my favorite features because if I worked with one application, I know how to configure it and I know how it's going to be the structure of the other ones. And this is not imposed at the framework level. This is imposed at the language level. Okay, so this is really nice. So if I work with one, it's very likely that I will be able to work, configure, and customize other applications too. And because the applications have the supervision tree, right? The application is going to hold all processes and all the state that is part of our application, because all of your code here runs inside those processes, right? And if the application can see all those processes, it means it can introspect them and see what is happening. So what I want to do is that I want to show an example of exactly that. Okay, so here I'm going to open up my terminal. And you can't see it, okay. I am going to mirror the screen, just 1 second. Huh? Where is my mouse? Okay. Okay, so we are back on track. So while it was mirroring, I started this thing. So here is an interactive Elixir console, right? You just type Elixir code, and this is running inside a Phoenix application. Okay. So what I can do here um, is I can call this tool called Observer, and it's going to bring for this node. It's going to bring this panel with a bunch of information about my system. Okay. So here is we can see here we have a bunch of tabs here at the top, and here we can see general information about my system, right? So what is the virtual machine version I'm running, how many cores it can see, how much memory it takes. So it's around, so Phoenix takes, after you boot it and have everything up and running, take around 26 megabytes, right? And you can see at each, how much of that memory each component is taking, right? How much is spent on code, how much is spent on the processes, and so on. Okay, it has statistics about other stuff like what is the uptime and whatnot. So this is really nice. It gives a nice overview about the system. And we have load charts. There's nothing really happening in this application, so nothing interesting is going to come on the load chart, but it's there. And what I really want to show, so if you're talking about processes, right, we have this tab with all the processes that are running on this on this system. Okay, and the nice thing is that all the named processes. And the nice thing is that I can check here what are the processes. So let's suppose you have a memory leak, right, in your application. I can see here, I can order by the memory and try to find out what is the process that has the memory only growing and growing. And after I find that, I can double click it, right? It's going to open up another panel with all information about that process, which code it's running, what is the state, what is the stack trace, what is the relationship with other processes. So this is great, right? Because everything runs inside those processes, and I can actually introspect, and I can monitor, and I can see what is happening on each of those, okay? Not only that, right? If we go to the Applications tab, we can see all the applications. So remember, as I said, when you run your Phoenix project, you don't have a single application. You have a bunch of applications, right, that are started as and stopped as a unit and running side by side. And we can see all of them here. So Elixir itself is an application. So here's Elixir supervision tree. It's actually quite simple. There's not a lot happening here. But if I go, so this application is named full, okay? So if I choose the full application, we can see the whole application supervision tree for the Phoenix project, right? So here I can see that my application has a supervisor, okay? For example, we said that there's a pub subsystem. So somewhere around here, so somewhere around here, we can see that the pub subsystem has a child supervisor, and it has the pub sub process with something that is responsible to send the messages locally. So I can really go into each of those applications and say, what constitutes my system, right? And I can click those things, and I can introspect and try to learn more about my system. But the most important of all, and the last thing I want to show is that, as I said, because you are thinking about processes now and you're thinking about supervisors, we start to think, hey, what is going to happen if something goes wrong in my system, right? If something unexpected happens. So here, for example, we have, let's choose the database pool for that. So here we have the database pool, right? So here's the pool manager, and all those things, they are connections to the database. And you can see that they don't have names, so they are identified with this thing here, this, we call it a process identifier, which is 0.275.0. So, and then we have, this pool has 10 connections. So let's imagine, let's simulate that something goes wrong with the pool, okay? So I'm going to send it a kill message. Because I have supervisor, what we expect to happen is that the supervisor is going to notice that the pool crashed, right? And it's going to bring another pool back. And when the pool comes back, the previous pool lost all the connections, so it needs to establish the connections again. So if we go back there, it's exactly what happened, right? We can see here that we got new identifiers for everything because that pool and all the connections, they crashed, right? They were gone, but we start a new one and our system is fine. Everything is up and running, okay? So, so to drive the message home, okay, if you're talking about applications, and how they impact the long-term productivity and reliability of our system, it's because it brings a lot of introspection and monitoring, right? It's easy to monitor my system, and I can introspect. I can go, if some node is misbehaving in production, you can go connect to that node, start up an observer, and try to understand what is wrong, or run some commands on the command line and try to get as much as information as possible. It brings the visibility of the application state. This is extremely important, right? If you're writing code in object-oriented languages, and I ask you, what is your application state? You have no idea, right? Because it's always scattered around class variables, singleton objects, right? You don't know what is your system state. You don't know how to introspect it. You cannot reason about it at all. Here is all inside those processes, and we saw how we can navigate those processes and introspect them. It's easy to break into components. It's extremely important. As your application grows big, right, you need to be able to break it into parts. And if we had that supervision tree, one very easy thing you can do is say, hey, this tree is growing too big at this point. What if I get like this branch and move it elsewhere, move it to another application with its own start and stop code, right? So it's a very easy way to break components apart because, again, it's all processes, right? Everything is explicit, communication is explicit, and so on. And finally, it brings us the reasoning when things go wrong. Because that's the ultimate truth, right? You can use the fanciest type system in the world, bugs are going to happen, right? Even more if you are running things on the network. Things are going to go, unexpected things are going to happen. Maybe the network is going to become unavailable for 10 seconds. How are you going to handle that? And the best way to handle that is to ensure that if something goes wrong, your system can heal itself. Okay, and the supervisors help with that a lot. They allow your system to go back to a state that is supposed to be running. So, to sum up, this is the talk about Phoenix. So, Phoenix is a web framework that's going to allow you to be productive for building reliable and fast applications, and you're going to have tons of fun with it, be it for building regular HTML5 applications, or API backends, or even distributed systems, more complex distributed systems. If you want to learn more, you can check the Phoenix guides, right? So go to the Phoenix page. There are a bunch of guides there. But if you want to learn more about Elixir and the idea of applications, I've talked at the end, you can go to the Elixir page. We have a getting started guide. We have a bunch of books available. Those are just some of them, okay? And finally, I want to thank my company, Platform Attack, for creating Elixir and investing in the community. And yeah, that's it. So that's the talk about Phoenix, and thank you very much.
Okay, so we can start and run packages inside an app. Can I hot swap my code? Yeah, I have a new version of a package, and can I change it without downtime?
Yeah, so the question is, can you hot code swap different applications? So hot code swapping is the ability the Erlang virtual machine has to update the code that is running in production. That's built with the module system in a virtual machine. That you can upgrade the code that's running in production without bringing the system down. And yes, it is possible, but it depends, for example, if the developers that wrote the particular package that you're using, if they are writing the proper recipes for migrating the system. Okay, so it's going to change on a case by case. If you're doing web stuff, because you already have a bunch of tooling for like do rolling upgrades at the HTTP level, like you have a proxy or something that you just swap, it's often easier just to do that. But if you need a system, for example, in the one, so we had Elixir conference last year in Austin. There is a talk that I recommend you to see about developers. They're using Erlang and Elixir, and they build a poker application. And the issue with the poker application is that apparently people are playing all the time, and the poker matches, they last 20 minutes. So there is no really a good time where you can say, hey, let's shut everything down and bring a new one, because when one match is starting, the other one is the middle, another one is ending. So they talked about how they are doing exactly this thing, right? How they are keeping the system up and running. They can upgrade the software, and they don't drop connections. The users, they don't see any effect in their games. So that's a cool thing to check out. Search for the videos or tweet at me later for Elixir Conference 2014.
It seems to me there's a lot of Ruby on Rails developers thinking of moving away from Ruby and Rails towards Elixir and Phoenix. Could you comment to when it would be a good idea to do that, or when it would not be a good idea?
So that so one thing, so there are a couple things to consider, right? So I believe Phoenix has, so concurrency and performance. It's going to be, I have like benchmarks from people actually replacing system in production, where they get 15, they can handle 15 times more load. So if they have 15 machines running Rails, they can replace by one machine running Phoenix. Um, and there are some cases coming out. You can watch videos from the Elixir conference that we had in Krakow 2 months ago. There are cases from people migrating, so, and those can give you an idea. So performance is definitely one of them, but the whole way of building applications that I said here at the end, it's also a very valid use case of how to think about my system. And the fact that we are really worried about the long-term maintenance is also a very good sign. So those are obviously pros that we get, and that's what I try to focus on the talk, right? What are the pros that we have with Phoenix? The downsides, though, which I think it's important also for our question, is um, it's still a small community. Okay, we are growing. We are having more and more events spread out, and a lot of people are coming. But you're not going to find like package for everything. Like, hey, I want to do upload. Yes, there is no package yet, so you need to figure out what is the best way to do upload. You're not going to have something that changes just 3 lines and then boom, it's working. Um, so that's one of the things, and the other one is that Phoenix, it's very close to 1.0, and but we are not 1.0 yet. And there's already a bunch of people using it in production, but it's not there yet. So those are the two main downsides I would have in mind right now. But it's the idea is to release it July, August, so it's at the right moment to start. And I've heard there are books coming out soon about Phoenix also. So that's another thing, like learning resources. But we are catching up quickly, and I think you're going to be in a good position soon where those downsides will be gone, and you'll have mostly upsides. Cool. Yeah. So thank you very much. Oh no, I'm sorry. Ah, well, talk to me later. Yes. Thank you.